So I'll continue on now with colliders. Let me get a share screen going. So colliders are invisible surfaces used for collision calculation. And they come in three flavors. There's primitive meshes, uh, mesh colliders, primitive colliders, mesh colliders, and wheel colliders. And the primitive colliders come in three shapes. You have the sphere, the box, and the capsule. And these are the simplest and fastest because the shape of the collider is defined by a formula rather than by the geometry of some complex object. The mesh is defined by the geometry of a complex many polygon object. And each of these primitive colliders, all colliders have these properties. They have a material, that physics material that I mentioned, defining how it collides with other objects. They all have an is trigger setting. And if the is trigger setting is set, it means that the colliders don't collide, but they instead send messages that can be received by a script. And something can then be done in the script based on the fact that a collider surface has been penetrated by some other object. And we use this a lot in scripting. The primitive colliders have different properties. The box collider is basically that, a box that has a center and a size given in terms of the Cartesian coordinates. The sphere also has a center, again, at some particular offset from the center of the object, and the radius of the sphere. Capsules have a radius that is kind of their width, but they have a height that is their capsule height. And you can also choose what direction you want that height to extend in. There is a rule of thumb that you should avoid having more than one collider in an object, although often we do, especially if one of them is a trigger that's defined, that's used for scripting. It's used to tell if a collider has been penetrated. But generally, you don't want an object with overlapping colliders. Primitives are generally good enough and are much, much faster and more efficient than the mesh colliders that we'll talk about in a minute. So right away here, I have a scene, I have a scene that has, here's a beam. So this is a cube that's been distorted to be 2 by 3 by 2. But look at this, I have on it a capsule collider instead of a box collider. You might be able to see this in the wireframe view, where my beam, which is this box, the collider is a capsule that is centered at 0, 0, 0, the center of the object. It has a height of 1 and a radius of 0.5, and its direction is in the y-axis, the green axis. At the same time, this little capsule, here's one, the capsule, it has a capsule collider, and so its collider kind of matches its shape. We have a capsule, and the collider matches the shape of this thing. Here's a sphere, and on this sphere, I've put a box collider that's not quite centered and has size 111, so it just encloses this. Now, when I run this thing, first of all, uh, my beam, notice it's not the visible geometry that is colliding with the terrain. It's that capsule that's colliding with it. My ball doesn't roll because it has a sphere, it has a box collider on it. My capsule does roll because it has a capsule collider. So those are the three primitive colliders, capsule, box, and I guess I didn't actually show a sphere there, but we had a sphere in the base scene here where we had a sphere collider on this red thing that rolls quite nicely as a ball. So those are all the primitive colliders. The mesh collider is a custom 3D mesh that can be used. It's generally the same as the mesh that we display, but we can sometimes simplify, use simplified versions for efficiency reasons. The mesh collider is much more computationally intensive than the primitive collider. And let me show you something that happens with the mesh collider. So here's my LERPS character. He's a mesh object with a lot of triangles. You can see him in wireframe here. He's a mesh object with lots of triangles. And his collider, his mesh collider, uh, uh, is not set here. Now, right away, if I were to play this, and let me turn on the error pause feature. In my console window, if I have error pause on, the game will stop whenever anything throws an error in the game. So if I play this, right away, it stops. And what it tells me is that we have a non-convex mesh collider with a non-kinetic rigid body. And it goes on to say that if you want to use a non-convex mesh, either make the rigid body kinematic or remove the rigid body component. So what that means over here, and if I continue on here, the other thing to watch is that it falls out of the world. Let me turn off the error pause and run this again, and you'll see that LERPS just falls through the scene and he's gone. That's because mesh colliders don't collide with things unless they are convex. So let me get LERPS back here. And now the one thing it's saying that it's non-kinematic. So I could also make this kinematic. And now it won't fall through the world because setting is kinematic means it doesn't participate in gravity. But it is a collider in the sense that I can bump up against it and it stops me from moving. So there is a collider there. It's a mesh collider, but it only works if it is kinematic. If you want a non-is kinematic collider, we get this error that we saw over here, but it was telling me that I had to make it convex. And here's the convex collider. Now what a convex collider is kind of a shrink wrap of triangles around the object. There are no embayments here. There are no indents into this thing. It's shrunk wrap around the object. The convex collider, there's his trigger. But now if I run this, now he stands there quite nicely. And I can go over and knock him over. And he falls and bounces around on the world the way you would expect him to. And what I'm colliding with is not the mesh of this character, but what I'm colliding with is that convex collider that wraps it. And the reason I can see that in the game view here is because I have gizmos turned off. If I turn off gizmos, then I don't see that. So with mesh colliders, they can't be non-kinematic and not convex at the same time. We have to do that convex trick to deal with it. A couple of limitations. The Convex Collider is limited to 255 triangles, so it can only be used with relatively simple meshes. Now, let me show you an issue of scale here. Let me take my lerps, and I'm going to blow him up. I'm going to make him big. And so now I have this giant lerps, and he still stands there, no problem. But if I try and run through the arch made by his legs, because he has this shrunk wrap convex collider around him, if I try and run in between his legs, he falls. And the other thing to notice is that if I try and go underneath his arm, where there's an apparent void, I run into the collider that goes from his fingertips to his feet. And so this mesh collider is not really capturing the spirit of what our giant lerps looks like. And so we often resort to something called compound colliders that use simple primitive colliders to approximate the shape of our object. I'm not sure the inflate mesh still exists here. That doesn't seem to be an option anymore in this version. So, so the kind of place this would come up is, say you had a sawhorse or an archway or something that had this hole that you wanted to go underneath it. And so we would make box colliders for each of the legs, and for the crossbeam across the top, we would make them children of the original object so that they were childs that would stick with it, make a prefab out of it, and away we go. Let me show you this with lerps. Don't save. So here's lerps now with compound colliders. And so you can see lerps, the kind of blue thing here, but you can see this compound collider that I've made to approximate his shape. I've got a sphere collider for his head. I've got a box collider for his shoulders. I've got capsule colliders for his arms, a capsule for his abdomen, and a couple of boxes for his legs. So I've made, oh, the box here is for his jetpack on the back. So I've made a rough approximation of the colliders that go with lerps. And now I can now successfully run through his legs without knocking him over. So the archway is now passable. I can still knock him over if I run into his legs, but now I can go up underneath his arms and underneath his head because I'm no longer encountering that compound collider that mesh collider that was in its convex form. So a warning about colliders. There are colliders interact with each other differently depending on what kind of rigid body they have. And there are three important configurations. One is the static collider. This is a collider that has no rigid body at all. This would be something like a building that we had set up in the world. It would have a static collider. The building is not a rigid body. It's not falling under the influence of gravity. And these colliders we can run into, and they stop our character from moving, and bullets hit them and so forth. Then there's the rigid body collider, what we've been just talking about here. These are colliders, these are rigid bodies with colliders that are fully controlled by the physics. And then there are the kinematic rigid body colliders. And these are fixed in position, or they're controlled by a script or animation, and they have a collider. Now, the place that this is different, a static collider is generally used for level geometry. We built piles of blocks or something like that for staircases, buildings, whatever. And rigid body objects will collide with that static collider, but they won't move it. It does not move. And because it doesn't move, the physics engine can make very useful optimizations based on this assumption that it never moves. Now, because the physics engine thinks it never moves, we should not move it. We should not change its size. We should not move it. We should not enable or disable it during the gameplay, as this will result in some kind of internal recomputation going on by the physics engine, which A, costs cycles, and B, can actually leave the collider in an undefined state that makes errors in the physics. For example, a ray cast against a static collider that's been moved could fail to detect it, or it would detect it at some position that it wasn't there. And in addition, rigid bodies that are hit by a moving static collider are not necessarily waken up. And so for these reasons, only colliders that are rigid bodies, that have rigid bodies, should be enabled or disabled, moved or scaled during gameplay. If you want a collider that is not moving, that's not affected by incoming rigid bodies, but can still be altered later, maybe through a script or an animation, then you should attach an kinematic rigid body component rather than no rigid body at all. A game object with a collider and a normal kinematic rigid body attached, this is fully simulated by the physics engine. It reacts to collisions and forces. It bounces around, rotates, does all the stuff. And these are the most commonly used colliders that we have for objects that bounce around in our world. A game object with the kinematic, kinematic property check can be moved. You can move it with a script or with an animation. You can modify its transform component, changing its rotation, its position, its scale. But it will not respond to collisions. Like if you hit it with a moving bullet, it will not bounce back away from it. It will stay where you put it. So kinematic rigid bodies should be used for colliders that can be moved occasionally, but that should otherwise behave like those static colliders. An example of this might be a sliding door, like a Star Trek door, that would normally act as an immovable physical object, but of course we can open it when necessary with a script. Also, unlike the static collider, a moving kinematic rigid body will apply friction, and it will wake up other rigid bodies when they make contact. Even when immobile, kinematic rigid bodies, colliders, are different from static colliders. For instance, if that collider is set to a trigger, then you must have a rigid body in order for it to receive trigger events. A static collider will not generate events. It has to have a rigid body. We sometimes use this property in scripting to change the kinematic property. An example of this is a ragdoll effect, where a character moves normally when it's being controlled by a player, but is thrown physically by an explosion or a collision, or when it dies. The character's limbs can be given their own rigid body component with is kinematic enabled by default. That means that the limbs will move by animation. And when the character is hit by the bullet or blown up or dies, that is kinematic property can be switched off for all of them, and they immediately behave as physical objects, and our ragdoll will fall down. I'll show you an example of this later. So I want to stop there. I'll pick up next time with the character controller, another physics object. I'll stop sharing, and I'll stop recording, and I'll see you all in class. Bye.